All right, guys. Well, you are watching this video because I'm not here today. So let's try to do example 1B, okay? We last night ended with example 1A. I know that was about 20 some odd minutes, so hopefully you guys survived, okay? Hey, 1B, here we go. Let's look at all the steps, okay? Step number 1, according to your steps, factor the numerator and denominator and write it in the lowest, and then find your domain. So let's factor first. So step 1, okay? And again, hopefully you know how to factor. So the factors are x minus, guess what it is? Can you tell me? Oh, okay, x minus 4 times x minus 3. Well, let's see if that works, okay? So, negative 4 times negative 3, negative 2. That looks good. Let's double check to see if this is okay. X times negative 3 is negative 3x. Negative 4 times x is negative 4x. Whoa, is that going to give me negative x? Not really. Okay, so let's erase. All right, it didn't work. Remember, when you're factoring, make sure you also check. What else do you want me to try? What two numbers multiply gives you 12? And when you add, gives you negative 1. Is it possible? Okay, so I'm gonna make you x, so some of us are more visual. What two numbers multiply 12? And when you add, give me negative 1. We try negative 4 and negative 3. When I add, it's a negative 7. That didn't work. Okay, can we try positive 4 and positive 3? When I add, what do we get? Not working. So that's not working either. What should we try next? Should we try 12 and 1? When I multiply, I get 12, but when I add, would I get negative 1? Nope, that's not working either. Okay, so what can we do? Is it not factorable? If you said not factorable, you are correct, okay? So what I'm going to do is I'm just going to write it all over again. X squared minus x plus 12. Okay, all of that is divided by the bottom. The bottom is actually factorable. X plus 1 times x minus 1. So step 1, factor. It wants you to find the domain. The domain is just simply going to be all real numbers, not including positive and negative 1. Okay. Step number 2. We are now going to see if I can write it in the simplest form. Well, it's not possible, so I'm just going to write either the factor form from step 1 or the original from the given. Okay, either one is not incorrect. You can choose. So x squared minus x plus 12 all over x squared minus 1. So step 2, all they wanted to do, if you remember, is write it in the simplest form. Step 3, locate the X intercept and the Y intercepts, okay? So if you remember on step 3, from the previous example, X intercept is now just simply taking this numerator and setting it equal to 0. So x squared minus x plus 12. Okay, equals to 0. We know we tried how to factor that out, but if we can't, so I'm just going to write using the quadratic formula. So negative b, so it's going to be positive 1 plus or minus b squared, so it's going to be negative 1 squared minus 4 times a, which is 1, times c, which is 12, all over 2 times 1. Okay, so this is going to give me 1 plus or minus under the radical now. It's going to be 1 minus 48, which is a negative 47, all over 2. Well, it's a negative under radical, so that's not possible. So we now know that there is no x intercept. That means it would never cross over your x-axis, okay? Y int is when x's are all 0. So y equals 0 square minus 0 plus 12 all over 0 square minus 1. So that's really 12 over negative 1, which is really negative 12. And you can write it 0 comma negative 12 as well. So we have a y-intercept. Okay. Okay, so that's just step number 3. We found the intercepts. Let's look at step 4. Step 4, locate all of your VAs. Okay, in this case, you're going to have 2 VAs because when you factor it out, okay, when you factor it out, you have 2 things. So x plus 1 times x minus 1 set equals to 0. So your VAs are x equals to negative 1 and x equals to 1. So we are now down to step number 5. Step number 5, draw a number line. And I want to make sure that I added in an extra thing there at the end of yesterday's video notes. And I want to make sure you guys got it, okay? Draw a number line using your x-intercept and VAs to find the intervals on which the graph of R is above the x-axis and below the x-axis. So now I'm going to go and draw a number line. This is step 5. Using x-intercepts and VA. Well, x-intercept, there wasn't any, so I'm not going to use x-intercept. And VAs, I'm going to have 2, so I'm going to use both of them, okay? So here we go. We have negative 1 and we have 1. All right, let's plug it in. I'm going to start from left to right, okay? I'm going to use R instead of F then, because the equation starts with R. So here we go. R of, let's pick negative 100. When I pick negative 100, and yes, you can plug it in into the original or the, excuse me, or the original or the factor form. It doesn't really matter, okay? So when I plug into the original, negative 100 square on the numerator is going to be positive. Excuse me. Because all you need to worry about is the power function there. On the bottom, it's also negative 100 squared. It's also positive. So I know it's going to be positive over here. In between negative 1 and 1, I should have 0. Well, we did that already. Okay, I want to show you where. See this right here? When x is 0, y is negative 12. So guess what? It's going to be negative. Then I'm just going to plug something in super ginormous on the right-hand side. So on the right-hand side, when 100 squared is positive, divided by positive, it's positive. All right. Pretty good, right? So that's step 5. Let's see what step 6 says. Step 6, locate your HA or OAs, and then tell me if it intersects or not. I'm running out of space. Oof. Step 6. Here we go. Well, let's look at the degree really quickly. The degree on the top is 2. The degree on the bottom is 2. So therefore, it's definitely an HA. Okay? And in HA, all you do is you take the end behavior on the top, which is x squared, divided by the end behavior on the bottom, which is x squared. You must reduce, so this is y equals to 1. So this is your horizontal asymptote. Step 7, you are to graph it all by hand, my lovely students. So here we go. All right, let's see. I have a negative 1 VA, a positive 1 VA. So let's graph those out first. I'm just gonna, let me do some more tick marks, okay? I have 12 on the bottom, so I'm just gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm gonna extend it a little bit more. Erase, extending the line. Did I say 9 already? 10, 11, 12, okay. Here we go, on the top, let's do a couple. So my VA, the first one is going to be at negative 1. And the other one is positive 1. Okay. I have 2 VAs, meaning I should have 3 curves. Okay. I have an HA at y equals 1, so it goes like this. Okay, I don't need to make tables or anything. That's the nice thing about this. But I am going to use the y-intercept to plug in. So y-intercept, it's at 0, -12. Okay, I don't have any x-intercepts, but I have this awesome table. See this right here, this line to help me sketch out my graph. On the left-hand side of -1, it says everything must be positive. So that means I'm putting it above here. I don't need dots. Okay, I don't need anything. I just need to follow the asymptotes. In the middle, it tells me everything needs to be negative. So, oh, you know what I missed altogether? I need to see if this right here, oh snap, intersect. Okay, intersect HA or not. Okay, I forgot that piece. Okay, so again, how do we determine if it intersects an OA or HA? We take the y equals, which in this case is 1, equals. They're both y equals, so we're going to put it equal to step number 2 equation, okay, which is x squared minus x plus 12 all over x squared minus 1. I'm going to make this into a fraction so I can cross multiply. When you cross multiply, it's going to be itself because it's multiplied by 1. When you cross multiply the other side, again, it's itself because it's multiplied by 1 again. So it's x squared minus x plus 12. These two terms are going to be canceled because they are exactly the same. But I can still solve for x from here. What I'm going to do is I'm going to minus 12 from both sides. Okay. So this is -13 equals -x. Divide both sides by negative. Oh my goodness. I do have an intersecting point when x is 13. When x is 13, y is 1. So it intersects at 13, 1. Holy cow. Okay. So I'm going to need a lot of x's on the right-hand side. Hopefully I have enough space. All right. I have 1. Oh, you know what? I already made that. Okay. So yes, intersect at this point, okay? So I need to go in and make everything into 13 units. Here we go. So 2, 3, 4, 5, 6, 7. I need to extend some more. 8. Oh, gosh. You know what? I have to erase this. I just need to make it smaller to fit all 13 units. Sorry. Okay. All right. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yay. Okay. I need to go back and draw in that intercept at +1. I mean, not intercept VA. Okay. It looks so not even, but I totally screwed up. So sorry. All right. So now I'm just going to go in and connect that VA and HA back. So my VA at 1's back, my HA at y equals 1's back. Okay, so now, what do I do with this point? Okay, so at 13, 1, it crosses, oh my goodness, my HA right there, that dot, exactly, okay? So what's happening? Let's go back and look. So in the middle, everything has to be negative. So in the middle, it's going to be a parabola opening down because that's the only way that's going to be negative. And I'm just going to extend these asymptotes some more. Okay. Then on the right-hand side, okay, on the right-hand side, it says here everything has to be positive. And you have to look at this very carefully. That means we're on the top. Okay. Oops, let me get a different color pen. So we're on the top. And then we're going to, watch this. I'm going to approach the asymptote and I'm going to cross over and go under. But at no point I need to be under the x-axis. Okay, so keep that in mind. I'm going to continue this x-axis out here. So at no point it can be under the x-axis. It would never loop back above the horizontal asymptote. It's still going to be below the asymptote, but it would never get below the x-axis. The curve, the function, the rational function, it's always going to be hugging, okay? I'm going to repeat this. It's always going to be hugging or approaching the asymptotes. Even though if it crosses over, it should still be near the asymptote. So again, at no point, I'm going to highlight this so we can see it. At no point this corner over here should be going back above the horizontal asymptote. It's now below, but it would never go underneath the x-axis, okay? Now, I understand that some of these are fast, or if I'm saying too fast or talking too fast, you can ask anybody in the class that's running the class to slow down for you. Okay, let's move on to example C. Yes, we are, okay? Example C, let's look at our step 1. Step 1. H of x equals, let's see if I can factor out. On the top, it's x squared plus, so that would not be factorable. On the bottom, I know it's the difference of 2 squares, so I can factor it out into an x squared plus 1, and then an x squared minus 1. But crazy, right? I can factor some more. Look, okay, on the top again is not factorable, but this one is, again, is still a difference of 2 squares. So I can factor that. So it's going to be an x plus 1 times an x minus 1. Okay, in addition to factoring, it also wants you to find the domain. So the domain is going to be taking all the denominator and set it equals to 0. So here we go. So x squared plus 1 times x minus 1 times x minus, I'm sorry, this is an x plus 1. Times an x minus 1, and then equals to 0. Take each factor and set it equals to 0. If I do that, here's the first factor. This next one is going to be x equals to negative 1, and this next one is going to be equals to positive 1. So what happens when I solve for this? I have an x equals to negative 1. Then I'm going to take the square root, right? Oops, I just moved. My bad. Let me fix it really quick. I just moved my recording line, so I need to move it back. Okay, so this is, I need to take the square root of x, so that's going to be square root of x equals square root of negative 1, which is really imaginary. So because it's imaginary, it's not part of your real solution domain. So my domain is going to be all real numbers, not including 1 or positive 1. I'm sorry, positive 1 or negative 1. Step number 2, can I reduce it? And the answer is going to be no, I cannot reduce any of this, okay? Because I can't reduce it, you can just write the original, which is fine by me. X squared plus 4, and yes, this step is mandatory, okay? All right, step 3, can you locate the x-intercepts and the y-intercepts of R? So step 3, here we go. Let's do x-intercept first. X-intercept is, again, just take the top, the numerator, and set it equals to 0. Let's solve for it. It's really x squared equals negative 4. We are now going to take the square root, okay? When you take the square root of negative 4, that's not possible, so there is no x-intercept. And please, if this is going too fast, you can definitely ask to be, for the video to pause so you can finish writing, okay? Now let's look for y-intercept. Y-int is when all the x's are 0. So h of x equals 0 squared plus 4, 0 to the 4th minus 1. So this is really 4 over negative 1, which is negative 4, which I'm going to write it as a point. Okay, and this is your y-intercept. Step number 4, locate your VAs. So let's see if we can do that. Locate your VAs is the same as is related to your domain. So I'm just going to take whatever the domain that you excluded. Those are your VAs. So the VAs are at x equals to negative 1 and x equals to positive 1. Okay. Step 5, draw a number line using the x-intercepts and your VAs. Okay, so here is step 5 on this. I'm just going to use as much as I can, trying to squeeze. Here's a number line. You have no x-intercept, but you do have two VAs. So let's plot on here, -1 and 1, okay? All right, let's see what we're doing. Let's pick some really large value on the left, so -100. And I'm just going to use the original function h of x at the very given, okay? So -100 squared is going to be positive, because that's your power function. -100 to the fourth is positive, so this is going to be positive, okay? Next is I'm going to pick some value in the middle, which is 0. Whoa, crazy, right? I already have 0. Look. Okay, so I know right away that it's just going to be a negative, so that's that one right there. Then I'm going to pick some ginormous number on the right, which is, let's say, +100. So +100 squared is positive, divided by +100 to the fourth power is positive, so this is positive. Okay, so those are the direction that we will be graphing. Then our next one is going to be step number 6. Step number 6 says locate your HA or OA and then tell me if it crosses or not, which I tend to forget, which it's super important that I don't. So the degree on the top is 2. The degree on the bottom is 4, so this is definitely an HA. So y equals, the end behavior on the top is square, the end behavior on the bottom is x to the fourth. We're going to reduce, it's going to be 1 over x squared. As x approaches something super ginormous, like -1,000 or +1,000,000, y approaches 0. So that is your HA. Now let's see. Intersect HA question mark, right? Because I need to show this. I forgot it last time. So we're going to take 0. And we are going to set it equal to your original equation or the factor form. That is not important because they are both not reducible. So we're going to have x squared plus 4. Sorry, lost track. So x squared plus 4, and then divided by x to the fourth minus 1. Well, we are going to cross multiply, but when I cross multiply, that right there is 0. Okay, so 0 equals x squared plus 4. Let's try to see if you can solve for x. Subtract 4 from both sides. X squared equals -4. When you take the square root, that's not possible. So intersect HA? The answer is no, it will not, which is different from previous example, okay? In the previous example, it did cross at positive 13,1, but this one is not going to. So make sure we are moving on up here, my bad. Okay, so we are now on step 7. Okay. Step 7 it is. Step 7, we're going to sketch it out now, so I'm hoping I have enough space. Okay, I'm just going to use a different color for my VAs. Okay, I have two VAs. They are at -1 and +1. I don't have any x-intercepts. I do have a y-intercept at 0, -4. There you go. I do have a horizontal asymptote at x equals to 0, so I'm going to extend this line. Okay, so besides those things, I don't have anything else to plug in. I'm not going to, if you look at this, I'm not going to touch my x-intercept, I'm sorry, not x-intercept, my HA this time, okay, so keep that in mind. So, but I'm going to use this number line right here to help me sketch out the rest of my curve. So, let's look at the very left-hand side. Everything should be positive, so what that means is it should be above the x-axis. Do not touch any asymptote because it said so. The middle said it needs to be negative, so that means it needs to be a parabola opening down, okay? Because, I'm going to extend that dot, because if you have a parabola opening up, that means it's crossing your HA. But remember, we tested earlier that it should not be touching your HA at all. Then you have this thing on the right-hand side of your VA. It says it's also positive. So that's the curve that we are looking at. This is different, slightly different from example B, because in example B, we knew that it was supposed to be touching your HA. This one is not at all crossing over your HA. And again, just to remind you, feel free to ask for the video to pause a little bit so that way you can get it all caught up, okay? All right, we are going to attack example D as well. And example D is our last example of your video notes in class. So example D, similarly, we're going to start with step 1. Step 1, factor it out, right? Numerator and denominator, and tell me the domain, okay? So R of x equals x minus 3 times x plus 3. Those are the factors for the numerator. The bottom, I need to multiply to give me 18 and add give me 9. So I take it, I should have an x plus 3 times an x plus 6. Quickly and mentally check it, make sure it works, okay? 3 times 6 is going to be 18. And then when I add them together in the middle, I should end up with positive 9x. So that works. And it doesn't say to reduce here in step 1, so be very cautious. It just says to find the domain. And the domain is x can never ever be those two things, negative 3 and negative 6. Okay. Step 2 is when it says for you to reduce, okay? And that's all you do in step 2. Do not to do more than what it's stated in our instruction. So when I reduce it, I'm going to end up with an x plus 3 on the top. And, I'm sorry, not an x plus 3, but an x minus 3. All right. And then on the bottom, I'm just going to, because I'm crossing out the x plus 3. Then on the bottom, I'm going to have an x plus 6. Well, so this is where we are going to work this out. Because we cross, okay, and this is super important, because these two things, class, are reduced or crossed out, it doesn't just go away per se. It created a hole. Okay, so this is something brand new that we need to understand. It creates a hole at x equal to negative 3. Okay, and how did I get that? All I do is I take it x plus 3 equal to 0, and then I solve for x, okay? So it creates a hole at negative 3. Well, I need to plot this hole. So I have an x value. I need to get a y value. Need to get y by plugging in here, okay? So y equals, which is r of x equals, I'm going to plug in negative 3 every time I see an x. And if you look at it, there's an x here, and there's an x here, and that goes in there, okay? And then on the bottom, I should have another x, and that should go to negative 3 plus 6. I'm just trying to find a point, and a point, I'm going to need an x coordinate and a y coordinate. So these two x's, that's where it goes, okay? See that right there? All right, so let's plug it in and simplify. So y equals is going to be negative 6 on the top divided by positive 3, so y value is negative 3. So it creates a hole when x is negative 3 and y is also negative 3. I'm just going to write it in an order pair, okay? So a hole at negative 3, comma, negative 3. And it's so important that you have to show me this work, okay? So keep that in mind. We have to plug this hole in later. All right, look at that, your first hole experience. Okay, so step number 3. Step number 3 wanted us to locate the intercepts of R. Okay, this is the only one so far that is reducible. So make sure we use the reduced form from now on. Use the reduce or simplify form from now on. Okay. All right, so that's what I'm going to use, is the reduced form. So step 3, X Intercept. That means I'm just going to take the numerator, which is going to be an x minus 3, set it equal to 0, I meant. So you have an X Intercept at 3. Y Intercept, it was when all the x's becomes 0. So 0 minus 3 over 0 plus 6. So that's going to be a negative 3 over 6, which is going to be negative half, which is really 0 comma negative half. Okay. All right, moving on up. All right, that's step 3. Step number 4, it wants us to locate your VAs. And again, you are only using the simplified form from here on out. So your VA is going to be what you have in the denominator. Okay, so x is equal to negative 6. Okay, so I want to connect these two concepts here. So up to this point, we say that, hey, the VA is the same as the domain, but it's not in this case because there's a hole here, okay? So because there's a hole, we are also excluding the hole. But on a step 4, you only have one VA because the other spot, it's actually a hole. So keep in mind that not always your VA is in the domain, okay? So make sure you understand that if you reduced it, that means it created a hole. So your VA should be one less, okay? Step number 5, we're going to draw a number line and use the X Intercepts and your VA, okay? All right, you have one VA and one X Intercept. So one VA at negative 6, okay? You have your X Intercept at 3, okay? So let's try to see where it's going to be positive or negative. And again, we're only using your reduced form. Okay, so negative on the top, negative on the bottom is going to be a positive. Okay, so that's positive. Then we're now going to use something in the middle, which is R of 0. Okay, R of 0, we have already done that. It's here. So that's going to be negative again. Okay, then something ginormous on the right. It's like positive 100. Positive 100 on the top, positive 100 on the bottom is going to give us positive. Okay, so that's what we have. Then we are now moving on to step number 6. Can you locate your HH or OA? Well, which one is it? The degree on the top is 1. The degree on the bottom is 1. So it's definitely an HA. The end behavior on the top is X. The end behavior on the bottom is X. I need to reduce. So therefore, this is a horizontal asymptote at 1. And then we need to go and find, hey, intersect HA, question mark. Okay. So take your Y value from HA. Set it equal to your function R of X from your step number 2, which is X minus 3 all over X plus 6. You would need to make this into a fraction and then cross multiply. Then it's going to be an X plus 6 equals to, cross multiply that, X minus 3. You have X's on both sides, so they can drop. So 6 equals negative 3. That is not true. So the answer to your intersecting is no. Next one is step 7. This is our last one of today. Okay, let's sketch it out. Here we go. Okay. All right, y'all. Step number 3 says you have one x-intercept. So 1, 2, and 3. Here's an x-intercept. You have a y-intercept at 0, negative half. So here's 0, negative half. Step number 4, it says you have a VA at 1, 2, 3, 4, 5, 6. Okay. And step number 5 tells me that I need to use that in a little bit. Step number 6, it says you have an HA this way. All right. Okay, so let's use your step 5. Okay, here's step 5. It says on the right-hand side of 3, everything needs to be positive. Okay, so what that means is this. Okay, don't touch your asymptote because it says don't touch it. And it says from -6 to 3, everything needs to be negative. So connect it to your y-intercept, don't miss that, and then curve down. Okay, so this should be 2 curves. You have 1 VA, so 2 curves, one on the right and one on the left. And this is telling me I should go down, but I'm out of space. Everything on the left-hand side of -6 says everything needs to be positive, so it needs to look like that. Okay, now let's take care of the hole. Here's a hole at -3, -3. So let's go and count. 1, 2, 3, go down. 1, 2, 3. There has to be a hole right here if I were to graph it correctly. So what you need to do is go back and erase it. Okay, if you have a little pencil that's running through it, then you need to go back and make a hole. That's what it means. And you need to label this hole. My scaling is probably really off, huh? So -3, -3. Okay. And this is the end of our notes. Thank you for listening.